everyone, welcome back. So in this video we'll be looking at the inverse of a matrix, but before there are some things I want you to think about. All right, so we add, we subtract, we multiply. Must be wondering if we also divide matrix. No, we don't. But we are going to link some ideas with the inverse of a matrix and the division of real numbers. All right. So if we are given the number 2, what is its reciprocal? 2 is 1 over 2, which is a half. And we know that when we multiply both numbers, we get 1. So inverse of a matrix is the same idea. However, if we're given matrix A, we write the inverse. If we're given matrix A, we write the inverse as a to the negative 1. So that is its inverse. Same like half is the reciprocal of 2 and 2 is the reciprocal of a half. All right. We don't divide matrix and there are some similarities. We can rewrite the reciprocal of 2 as 2 inverse, right? Half. However, when we multiply a matrix by its inverse, we get identity matrix. Right, and our identity matrix with a 2 by 2 is 1 0 0 1. So the product of the leading diagonal are 1 and the product of the non-leading diagonal is 0. That's for our identity matrix. But how do we go ahead and calculate the inverse of a matrix? All right, so we are given the matrix A, and A is equal to 4, -5, 3, and 7. Okay, and we need to find its inverse. All right, so there are some things that we need to do. First, the inverse of the matrix is equal to 1 over the determinant times the adjoint. All right, so I've done 2 videos on determinant and adjoint. So if you don't know what those are, you can always search through the channel for determinant and adjoint and learn more about these. But we're going to do a brief working out of each. So how do we find the inverse of A? So A inverse would be equal to 1 over the determinant, and the determinant is the product of the leading diagonal. So 4 times 7 minus the product of the non-leading diagonal. So 3 times -5. And we are multiplying this by the adjoint. And how do we find the adjoint of the matrix? We interchange our leading diagonal So it's 7, 4. All right, and then we change the sign. So this is a negative. We change the sign of the other two elements. So this was a -5. It now becomes a +5. This is a +3. It now becomes a -3. And then we do our calculation. So it would be 1 over 4 sevens 28. And 3 times -5, -15. So minus 50. And we write back our adjoint 7, 5, -3, 4. All right, so continuing, A inverse is equal to 1 over 28, and it's a double negative, so it gives us a plus. So 28 plus 15, 43, times the adjoint, right, 7, 5, -3, 4. All right, so A inverse, with all we need to do is use our the 1 over the determinant right here and times it by everything that is in our matrix for us to get the A inverse. So 1 over 43 times 7 give us 7 over 43. 1 over 43 times 5 give us 5 over 43. And then -3 times 1 over 43 give us -3 over 43. And then 4 times 1 over 43 give us 4 over 43. So there we have it. A inverse 7 over 43, 5 over 43, -3 over 43, and 4 over 43. All right. Yay. All right, so I do hope you learned something in this video. Don't forget to give it a thumbs up if you like it. Share with a friend and tell that friend to continue that trend so that that trend will never end. And don't forget to subscribe. Subscribe. See you in my next video. Bye. Love you all.